How's it, guys? Welcome back to my channel. Thanks for all the subscribes and likes and comments. I really appreciate it. On this video I'm gonna be showing you how to control VSD, this boy right here, with digital IO. So 15 preset speeds. We're going to run 15 different speeds, and we're going to control it with this little relay PLC, FX3U 16MR. So it's got 8 relay outputs, and yeah, I'm just going to show you how to do that. So first things first, I'm going to have to switch on the power. So let's do that. Okay, so switching on the power, I've got a isolator. So basically I've got a breaker from my main supply, which then comes to this isolator. And so now I'm gonna switch on this isolator. So let's switch it on. Okay, the isolator is on. Now I'm gonna go to the breaker that's at the drive, but we're first gonna test if we have the correct voltage before we switch on the VSD. Okay, so now we in front of our breaker, well, the breaker in front of the drive, and we're testing between L1 and L3. So as you can see, we've got 404 volts there. There's my leads. Okay, so now we're going to test between L1 and L2. Okay, now we are testing between L1 and L2. Previously we tested between L1 and L3, and as you can see, that's 416 volts AC, and there's my leads between L1 and L2. So now we're gonna test between L2 and L3. Okay, and now we're between L2 and L3, and that's 414 volts AC. So there's a breaker, there's the reading. So it's very important to make sure that that you always make sure that if you're going to switch on equipment, that the voltage that you're going to supply to it is correct. Because I always make the joke that if the smoke comes out and you can't catch it fast enough, then yeah, you pretty much have a problem. Okay, so we're ready to switch on. I'm gonna switch on my three-phase breaker here, and there she comes on. Now I'm gonna switch on the PLC. That's my double pole breaker, and there, that's on. Okay, so the PLC doesn't get supplied with 220 volt single phase. This is a DS module, well, DS type PLC, which means it gets supplied with 24 volt from my 24 volt DC power supply. So yeah, just always make sure you supply the right voltage to a PLC. This one actually shows you there it takes 24 volt DC. So when you supply equipment, just make sure that you know what the PLC requires, otherwise you're not going to be able to catch the smoke. Okay, so now that all the power is on, What I like to do first is just check some parameters, basic parameters. We're going to go into PU mode. Then I'm going to go to parameter 2, that's my high speed, maximum speed, sorry, my minimum speed. Parameter 1 is my maximum speed. That I've set to 55 because in this video I'm going to run from 41 Hertz, then 42, 43 up to 55 because I've got 15 preset speeds set up on the drive. So that's my maximum speed. Then I'm going to look at my base frequency. That's 50 Hertz because this motor that I'm busy controlling has a base frequency of 50 Hertz, and that only depends on which part of the world you are. Then I'm going to look at my acceleration. That's 3 seconds. I can make it less or more, but I like 3 seconds is fine for me for what I'm doing here. Then I've got my deceleration, which is also 3 seconds. And then a very important parameter is my motor rated amps. And this motor is rated for 1.35 amps. So then I set parameter 9 to 1.35 amps. So just to show you, I can make it say 2 amps. And you got to be in PU mode. Not necessarily, there is a parameter that you can adjust to change parameters in external mode, but yeah, I'm going to do it in PU mode. So then I just press set, and once it flashes between P9 and the setting that you've put in, then you know the parameter is set. So let's just set that back to 1.35 amps. Come on, 1.35, and there I set it. So that's just some basic parameters you want to have a look at, and before you start up your motor. But now what I want to do is I want to go and run the drive manually from the keypad. So I'm going to see my hertz is 50 hertz. We can make that 51 hertz, and then we just set it. Once it flashes again, you know the parameter is set, and then we're gonna press the forward button. And if you want to stop it, you just press the stop button. Okay, so now if you want to see the amps of the motor, you're going to start it again, and then we're just going to press the set key once. And then if you want to see the voltage of the motor, you're going to press the set key again, and it will show you the voltage of the motor. So let's go reverse this time by pressing the reverse button. And now we're going to press the set button. And then we're going to press the set button again. And press it again to go back to the speed display. And then stop it. Okay, now I'm going to explain a little bit how I set up the 15 preset speeds. You only need 4 inputs to the drive to run 15 different speeds on the drive. So that's quite a cool feature. So we're going to open it up. One thing I want to mention is that if you don't have prior experience with automation equipment or electricity, I wouldn't advise opening up equipment or touching equipment, because it can be dangerous, and for your own safety, if you don't know, rather consult people that do know. That's just a little safety thing I want to mention here. Okay, so we're going to open the cover of the drive to show you the control wires. Okay, so we're going to start off with RL. RL is run low. That's my first digital input. Then I've got RM, which is run medium. That's my second digital input. And RH, which is run high, which is my third digital input. And then I've got RT, which needs to be programmed in the parameters to become a fourth digital input for multi-speed. Okay, so let's go to the parameters. First of all, we're going to start off with parameter 4. Parameter 4, which is usually your run high, that will be standard. If you're not going to do 15 preset speeds, you can use run high. That's usually 50 Hertz. Here I've set it to 41 Hertz because in my PLC program I take a data register value, I increment it or decrement it, and then I move that value straight into the outputs of the PLC to switch on the correct signals to run the speeds that I want. So that's parameter 4. Parameter 5, which is your run medium, that's usually set to 30 Hertz. I've set it to 42. Then run low, which is parameter 6, I've set that to 44. Okay, and then we're gonna go to parameter 24. That's gonna be a fourth multi-speed setting that I've set to 46. Parameter 25 I've set to 45. Parameter 26 I've set to 43, and parameter 27 I've set to 47. So basically, just through those 3 inputs, RL, RM and RH, you will be able to achieve 7 preset speeds standard. But now if you want to go to 15 preset speeds, you have to create a fourth multi-speed, which I've used terminal RT, which I had to reprogram. So that's at parameter 183. Let's just get there. Now 183, the standard value is 3 for use of the RT terminal, but I've made it 8 so that it can become a fourth multi-speed. And then to go set up the remaining 8 speeds, you have to start with parameter 232. So that I've set to 48. Then parameter 233, which I made 52. Parameter 234, which I made 50. Parameter 235, which I made 54. Parameter 236, which I made 49. Parameter 237, which I made 53. And parameter 238, I made 51. And then the last parameter is 239, which I made 55. So that's how I'm able to use 4 outputs from the PLC here and switch 15 different speeds. So yeah, I'm going to show you the wiring next. So yeah, let's do that. Okay, so now I'm going to explain a little bit of the wiring. Now what is very important is that I'm using an external power supply. In my first ever video I used the internal power supply of the VSD, but yeah, I'm going to use an external power supply. So we start, basically, let's start here. I supply 24 volt from my power supply, and I supply my PLC's supply with 24 volt, because this is a 24 volt DC type PLC. Now secondly, I take also 24 volt from my power supply and I take it to all the commons of my outputs. So then I switch 24 volt through my outputs. Now what is going to be important here is that even if I do that, my driver is not going to recognize the outputs from the PLC to the inputs on the drive, which is RL, RM, RH, RT, STF and STR. So in that case, what you have to do is you have to take 0 volt from your power supply here, and you've got to common it with the drive's internal power supply, which is SD, and that's when your drive will recognize all the outputs from the PLC to switch them on. Obviously in such a case, because I'm using source here, I'm switching 24 out of my outputs to the drive's inputs. You have to make sure your jumper, you've got a jumper here that you can take from source to sync or source, but in this case your jumper has to be on source. Okay, then for my alarm input, which is X0, you can see it's on at the moment because I'm using a normally closed contact from the drive. You've got 2 relay outputs from the drive. I'm using the first relay. I take 24 volt from my power supply here and I put it to the common of the relay of the drive's alarm output, and then I use the normally closed contact and I bring it to X0. But because I'm using the external power supply to supply that relay, I have to use 0 volt coming from the power supply to my SS terminal on the PLC, so that it can recognize the 24 volt that is going to come from the drive. Then on my SE terminal, which is the common for the run and FU terminal, and no, I'm not swearing, but SE is the common for run and FE. So run is my drive running, FU is my up to frequency. This is an open collector, so you can supply it with 0 volt or 24 volt, but it's an open collector transistor basically, and I switch them to X1 and X2. Now I could have taken from PC terminal, because I'm only using the drive's inputs. I could have taken from PC terminal, it's somewhere around here, PC, there it is. I could have taken from PC terminal, I could have taken that 24 and jumped it to SE and then supply all my run and FU, as well as I could have taken from PC, I could have gone to the common of the drive's alarm relay. I could have taken all that and supplied it from PC, but then I would have had to use SD to my SS terminal on the PLC. But in a real application, if you've got sensors on the outside, limit switches, whatever, buttons, whatever, you're not really going to want to supply all those equipment from the drive's internal power supply, because it's limited. It's got a certain rating, and you can damage the drive's internal power supply, so it's not recommended. So in this case, I just supply everything from my external power supply. So yeah, that is the wiring. I think I've explained all of that, and now we're going to go to loading the programs. I've got 3 different programs that I've written. I've written one in ladder, I've written one in function block, and I've written one in text-based language, structured text, or ST, just to show that, once again, like one of my previous videos, I think it's preferential. I like ladder logic, so yeah. Okay, so yeah, I'm now on my PLC program, but before we start, I just got to remember to put the drive in external mode, because otherwise my signals from the PLC, the drive won't pick it up. It always has to be in external mode if you're working with external signals from a PLC or controller or whatever. Okay, my program, I've got X0 coiling M0, which will then say okay, everything is ready. Then I give a start request via M1. M2 is my stop request. Well, let's just stop. It will stop everything. So if X0 does go off my alarm, then everything is going to stop. Then I've got M4 for my start forward and M5 for my start reverse, and then once I've got that, I've got M101 up to M115, which is my preset speeds. There's 15 of them, so that's why I go from M101 to M115, and then I just move a data register straight into the outputs of the PLC. So I basically, let me just show you. If I want to start with my first speed, I switch on M101, and that will move a value of K1, a constant value, into my data register. Then as for my run signal and my up to speed signal, in front of every M bit that I activate to select the speed, once I've selected the speed and it starts up, my VSD run signal is gonna switch on, which means it will cut out this circuit, and only when my VSD up to speed signal comes on, then I will be able to select a next speed. So that's just a little thing that I did, just to make sure that you can't just go and choose the next speed, you gotta wait for the drive to get up to speed before you select your next preset speed. Okay, so first things first, let's go online with the PLC. Let's compare that my program that's on the PLC, or the program that's on the PLC, is the same as the program that's on my laptop or PC. Okay, let's go offline again. It didn't ask me. Oh, it did ask me, sorry, my bad. Okay, let's give a run request. That's on. Let's go to my direction, which direction I want to go. Okay, now the forward light should be flashing. If I want to go reverse, I just switch on M5 and I can go reverse. But there is some interlocking in between these two, so as you can see, once the one is on, the other one can't be on. You first gotta select it. So let's go forward again. Okay, now let's select our first speed, which is 41 Hertz. Now let's select our second speed, 42 Hertz. Now let's select our third speed. Okay, now let's jump it a bit. Let's go to our seventh speed, which is 47 Hertz. Let's go to our 10th speed, which is 50 Hertz. Let's go maximum speed, which is M115, and okay. Now let's drop it down to back to 41 Hertz. Let's just see if that's gonna go. Excuse me. Okay, and that's our switch between the speeds. Let's go 45 Hertz. Let's go something a bit different. 52 Hertz. Okay, and let's stop it. Okay, and now we're going to go to my function block program and see how that works. Okay, so here is my function block program. It's basically the same as my ladder logic one. Obviously function block just looks a little bit different. So yeah, let's go online with it. Let's compare whether this program is the same as the one on the PLC. And yes, it is. Okay, now let's give it a run request, switch it on. Now what's a bit different on function block and ladder is that here I've got to double click on the input that I want to switch on, or the input, and then I can't just use shift enter like on a ladder logic program. And you'll see I've got some pulses here. That's just for me that if I switch a input on, it will reset automatically. Okay, let's go reverse this time. Let's switch it on. Okay, let's just make sure, yes, the drive has got a reverse signal. So now let's go down to my speeds, and let's start with 41 and switch it on. Okay, that's 41. Let's go down to, let's go, I think this is going to be 45. Switch it on, close it. That's 45 Hertz. This is why I like ladder logic, because I can just press shift enter on the speed that I want to select. Let's go speed, what is that? Speed, let's go speed 11. That should be 51. That's speed 51. Let's go down to 55. There we've got 55. Okay, let's go 54. Close it. Let's go 53. And let's go to 44. Let's just see. 44, where's 44? 44. And yeah, let's stop it. That's just function block. So yeah, still doing the same thing, still do what I want. And stop us there. Okay, that's my function block program. So next up is the structured text or ST program. Okay, so here we are on the structured text or ST program. Obviously it looks a lot different than ladder or ladder FBD, but yeah, I've already written it, and so let's go online with it. Okay, this time it didn't ask me if I want to compare it, but anyways, I know it's there and it is correct. I just want to move that box up a bit. Okay, so it's basically the same as my ladder and FBD, same bits. So let's start with switching on M1 on. Okay, so now it's ready to get a start forward or start reverse. So let's go forward in this one. Okay, there we've got that. So my forward run line should be flashing, yes. And now let's go to speed 1 and 41 hertz. Let's start it up. Okay, let's go to speed 2, 42 hertz. Let's go to speed 3, 43 hertz. Let's go to speed, let's make it 46 hertz. Okay, let's go to speed 50 hertz. Okay, let's just close this and move this down. Whoops. And put it to 4. Okay. Let's go to speed, where are we? Speed 13, which is 53 hertz. maximum speed 115. Okay, let's go to speed 11, which is 50. I didn't show you that. 55 speed 11, which is 51. Let's go back to speed 15, 55. And now I just want to go back to speed 1 and go. Okay, and then we can stop it. So thank you for watching the video. If you like it, please like the video, subscribe if you want, and thank you very much for watching my video.